Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we are going to discuss about the emotion classification using deep learning and machine learning. Let's have a look at today's agenda. What are you going to covering on this project? So first, you're going to see that how can you load the data from a directory. That's called a load data. Then we have the EDA, also called exploratory data analysis. Then we have the data preprocessing like feature encoding or handling the categorical variable into the numerical one. Then we have the applying machine learning algorithms. So you're going to using here machine learning technique and also the deep learning technique. So for the deep learning, we're using here the LSTM, also called the long short-term memory. In order to removing the memory error in our RNN, you're going to using here the LSTM. Then you have the predictive system, nothing but you're going to building one predictive system. So here you can classify the emotions, and later on you're going to save this model in a file so that we can use it to creating the web application. And the last, you're going to creating here one Flux web application and try to test it out. So बिना किसी देर के हर हर महादेव बल के start करते tutorial. In order to creating the emotion classification project, we're going to use the dataset from the Kaggle. That's called the emotion dataset for NLP, also called the natural language processing. So this is our dataset. It having three files, test.txt, train.txt, and also the validation.txt. So this is the train.txt. You can simply download it from here. Otherwise, you can download this full dataset from here. So now what I can do, I'm simply going to click here. But before that, you need to create one account on that. Well, so you can see here in my working directory, it's called archive.zip. And this is a zip file, and after starting that, you can see here all the file that you see in the Kaggle test.txt, then train.txt, and also the validation.txt. So now what I'm going to do, I'm simply going to using the train.txt file in order to creating the machine learning model and also the deep learning model. And you can see here also one empty IP file, emotion classification using LSTM and ML machine learning. And for this project, you're using here the Jupyter Notebook. You can also using here the PyCharm or Google Schoolab itself. Well, so this is our empty IPN file that you see earlier. So now what I can do, I'm simply going to loading here all of the library that is required into building here the machine learning model and also deep learning model. So first thing first, I'm going to importing here the library for the machine learning. Then I'm going to import here the library which one is required into building the LSTM model. So first I'm going to importing here the pandas SPD. Then I'm going to importing here numpy SNP. So let's import, okay, import numpy SNP, which one is a basic library in order to building the machine learning model. Then I'm going to import here the pickle because I need to also save the file, save the model file. So that's why I'm going to importing here the pickle. Then I'm going to importing here the NLTK because this is on natural language processing based tasks. So that's why I need to also import here the NLTK. Then also I'm going to import here the RE, nothing but called the regular expressions in order to checking the regular expression and try to remove it from my data set. And then I'm going to import from NLTK NLTK.steam, and I'm going to import here the porter steamer. So porter steamer, you can also using here the tab from your keyboard, and it will give you the auto suggestions. But first time it will take time, so it's simple. I'm going to type it out. Yeah, porter steamer is giving the suggestions. Porter steamer. That's it. So that's the nothing but for the ML packages. But I need to also loading here some things like word cloud or the Seaborn, because I need to also show the data preprocessing tasks here and also the data visualizations. So that's why I need to also import here the Seaborn. So Seaborn as SNS. Then I'm going to importing here the matplotlib dot pyplot as plt. Then I'm going to importing here the word cloud so that you can see the word cloud of our data set, because there are 6 types of classes available inside my data. I mean train.txt file. So for that I'm going to also importing here the word cloud. So word cloud. Then I'm going to importing here the word cloud. So word cloud like this. Then what I'm going to do, I am simply going to also loading here the level encoder, because it is also needed, because you need to also do the data preprocessing task for the feature encoding. So that's why I'm going to import it also. So let's say from sklearn dot preprocessing. Then I'm going to importing here the level encoder. That's called the level encoder. Okay, because you need to also do the feature encoding here. So this is the library for the machine learning. Then I'm going to importing here the library for also for the deep learning also, so that we don't need to actually import is all of the library again and again. So now I'm going to importing here the library for the deep learning. So for the deep learning, we're going to be using here the LSTM, also called the long short-term memory. So first I'm going to importing here, let's say from Keras dot models, and I'm going to importing here the sequential model because we need to using here the sequential models. That's why I'm going to using it here. So sequential, then from Keras dot layers, and I'm going to importing, okay, sequentials is 2 times because it will give me the response lately in the tab keyboard. So from layers, I'm going to importing here the embedding layers. Okay, embedding layers. Then we have the LSTM layer, LSTM. Then we have the dance layer. The last one you can actually add it here, and also the dropout. Okay, in order to getting overwriting from the overfitted or underfitted problem, that's when it's actually using here the dropout. Then I'm going to also import here the callbacks. So let's say Keras dot callbacks. I'm going to importing here the uh, earliest stopping, which one is really popular. Then I'm going to importing here the one hot encoding also. So let's say from Keras dot preprocessing. Then I'm going to importing here the one hot. Okay, also called the one hot encoding. Uh, so the one hot is nothing but available inside the preprocessing.txt. So I need to also import it like this way. Preprocessing.txt. I'm going to importing here the one hot. Then from the sequence, I need to also import here the pad sequence because we're going to using here the deep learning technique, and we need to creating this data, the textual data in a sequence of pad. So that's why we're not actually using here this pad sequence. So let's say sequence, and I'm going to using here the pad sequence. Okay, just going to import it from the keras.preprocessing.sequence and importing here the pad sequences. Okay, so pad sequence. Okay, like this. Now I'm going to importing here also the categorical because for the Keras, we need to also convert them the numerical data into the categorical data to the numerical. So that's on to importing here the two categoricals. And if you have the multiple number of classes, so that you need to actually convert them into categorical, not the binary types of cases. And also you need that we have the 6 classes. So that's why this is nothing but one multi-task classification likes of problems. So that's why you're actually using here the optimizer just like the categorical cross entropy. So that's why I need to also import it. So let's say for Keras dot utils and actually even importing here the two categoricals. So two categorical, and it actually import it like this way. So let's try to shift enter and try to check this. Okay, pad sequence is not available. I think it should be the Keras underscore preprocessing. That's why it's not actually importing. Okay, in the latest version of TensorFlow, you need to using his Keras underscore preprocessing, not Keras dot preprocessing. Okay, that's really fine. We import here other library for the machine learning and also deep learning. So let's give in here some hint. So machine learning library, and that's about the deep learning library. Okay, that's about the deep learning library. So let's make it like this: deep learning library. I'll go slower so that you can learn about these things very slowly. Okay, so now what I can do, I am simply going to load the data. This is our data. So let's click on here, train.txt. So this is our data set, and I don't know that how many classes are available in our data set. It's nothing but having the 6 classes. That's why it's a multi-task, multi-classification types of problems. So you can see this is nothing but one text, and based on this text, you can see here the setness, and also having a separator here. So this is one textual file. Now the problem is how can I actually read it using pandas? Yes, we can actually read is using pandas, just using here one separator keyword in our read underscore CSV. If you don't know about the pandas, just go on my YouTube channel and try to follow the Daredevil Python machine learning library series. Here we're discussing the pandas, about everything about the pandas, that how the pandas actually look like and how can you read the file from here. Different types of file you can actually read it using pandas. Same things you can also read the file that's called a txt file also. Now let's see how can I read it out. Okay, so for that what I can do is simply going to using here pd dot read csv. Now the question is, bro, it's not a CSV file, but how can you actually read the txt file also? Yes, we can do that. We can do that using the separator. Is a separator a parameter is available inside this read underscore csv. So what I can do, I am simply going to giving here the path of my that. So let's say train.txt. Then inside that there is a parameter is called the separator. It's called a separator. Okay, it's called a separator. So inside this separator, what I can do, I'm simply going to giving here this. Okay, giving here this one. Cool. Now what I can do, I am simply going to using here this header. So let's make it header should be none because it don't have any header. And also if I try to giving here two names, because in our data set we see that there is nothing, there is no name actually available in our data set, you can see this is just nothing but one textual data. It don't have any header. It don't have any header. So that's why giving here the header should be none. This is also one way how can I reading my txt file, right? So that's why I chose this one projects. So now inside this names, so what I can do, I'm going to giving here one name. So one names is nothing but called the comment, and another is nothing but called the emotions. Okay, it's called the emotion. Okay, fine. Now what I can do, I am simply going to giving here encoding. So encoding, this is the encoding for the textual data. It is nothing but called the UTF-8. That's one. Okay, now let's assign it to the variable. Let's call that train data. This is nothing but a train data. So train underscore data, this one. Well, so now if we try to checking this one train data dot head, then you can see it having the two column comment and the emotions. So we can also add here extra column on that just for calculating the length of the comment. So what I can do, we simply going to click here to add one shell, and to creating here another column that's called the length. Okay, length sample. Okay, now what I can do is simply going to creating here the length of that. So let's say for x in list comprehensions from the train data, and I can using here the comment. Okay, so just for getting the length of the comments, so if comment, it will give me this kind of way. List comprehension, it will actually creating here the length on that. Okay, you can see here also length is available 23 108 like this way. Cool. So now what I can do, our data is loaded correctly, so we can check the shape of our data. So for that, I will using here this train underscore data dot shape. Well, so you can see it having a 16,000 data available in our column in our data set. It having 16,000 rows and having three columns. This is our shape of our data. So now what I can do is simply going to checking that is there any missing values available in our data set. So train data dot is null dot sum. Okay, slowly ja raha hu. I'll go slowly so that you can actually understand everything clearly. Okay, so you can see train data dot is null dot sum. It don't have any null value in our data set. So you can also checking for the duplicate value also. So what I can do is simply going to copy this out and try to paste it here. Just instead of is null, we can using here the duplicated. Okay, duplicated. Okay, is there any duplicated value available? Yes, it's having one duplicated value, just one value. So we don't need to handle this one. If you have the more amount of duplicate value, we can simply going to remove this out. We can simply going to remove this duplicate value. Okay, it's don't have any null value. That's mean data set is straightforward. Data set is straightforward. If you have the noisy data, it will also handling this out. But when I go to the deeper to these projects, I mean deeper to this series, we will try to taking more advanced types of more noisy types of data and try to handling this out. Well, so now our data loading part is done. So now let's have a look the EDA, that's called the exploratory data analysis. So let's try to explore the EDA also. Well, so first what we're going to see, we're going to see that how many classes are available. I know it's having 6 classes already. So what I can do, you can using here the count plot from the SNS. So count plot, and I'm simply going to passing here my X should be my train data, and I'm going to using here the emotion. You can also using his train data dot emotion like this way. Otherwise, you can also using this way. Okay. Now I'm going to using here plt dot show. Okay. You can also using here the style on here, just like plt dot style. You can actually using here use ggplot. This kind of things you can actually using it here. Okay. So you can see here this is our data set. It's just having the more than 4,000 are nothing but sadness, and more than 2,000 is nothing but called the angers. Also love, surprise, the fear and joy, but joy is the most amount of. Well, so but little bit amount of the surprise. Okay, so now what I can do, I'm simply going to checking the data distributions. This is nothing but EDA for actually checking. Just have a look about your data, that how our your data look like, and also you can add it inside your thesis paper or your journal or your research paper. You can actually do that. Okay, so now let's have a look the data distributions, that how our data actually look like, that how the data is actually distributed in our data set. Okay, so for the distribution, I'm going to check, I'm going to actually taking here another data frame, just taking one copy for that, so that our data is not going to lose for the distribution purpose. So what I'm going to do, I'm simply going to using here df2 and taking the length of that length okay, length, and then I'm going to taking length of my other columns. So what I can do, I am simply going to copy this one for getting the length of that, So what I can do, I am simply going to now convert this length value, into the numpy array, so that we can actually plot it just like the hist plot. You can also using here the KD plot also. So I'm going to just getting the values from that so that it converted to be the numpy arrays. Now let us send the variable. Let's call the length value. This length value is not necessary, just for ensuring that if it is needed in the later on, so that you can actually use it. Okay, so let's say sns dot hist plot, so that you can see one histogram plot that how our data actually look like. So in our data, I'm simply going to passing here df2, then inside this x, and I'm going to giving here length, and after that in the hue, and I'm going to giving here the emotions. Based on the emotion, it will actually try to see the data, and you're going to using here the multiply. So if there are multiple number of classes, so we're simply going to make it a stack, and after that I'm simply going to show it out. So that's the plt.show. Okay, plt.show. Okay, so you can see here how your data set look like. The distribution of a data set in the first all of the data is nothing but the set, then having the angers, then having the love, the surprise, the feared, and so joy. Okay, this is how your data set actually distributed. Okay, you can also using here the one ggplot. So let's start using here plt.style style dot use. Let's using here the ggplot. Then what I can do, I'm simply going to use it here. I don't know it is working or not. Yeah, it is working. Now you can see the data, I mean the distributions graph, and also the graph for the count points looks like better than the before. The emotions, the sadness, how it looks like, and also the distribution of your data set. You can also adding here the size of your figure. You can actually do that, but I don't think that this is necessary. Okay, now let's try to also creating here one word cloud, because you also import it here. You are creating one NLP project, but you're not actually creating here the word cloud. That's not a okay. Yeah, you know, to creating here one word cloud. So now what I can do, I'm simply going to define here one uh, define here one functions which will actually help me to creating the word cloud, because we have 1 2 3 4 5 6 types of classes. So that's why I need to creating this word cloud based on the 6 classes. So that's why I need to simply going to using here one method, so then which one actually help me to do the word cloud. So word cloud. Okay, so it will taking one word cloud. So word cloud, then taking our data frame, let's call df. Now first time I'm going to importing first time I'm going to actually giving here a figure size, because word cloud, for creating the word cloud you need to also mention here the figure size. So let's say plt.figure, and inside this figure size I'm going to giving here my fixed size, and let's giving here on fixed size, let's call 10 comma 10, 10 comma 10. Then after that I'm going to giving him one title. So let's say plt.title. Okay, title. So what kind of title? So let's say the title is coming from our data frame, let's call df. Then let's say word cloud, word cloud. Okay, like this way. Then let's giving here a size. So let's giving a size should be the 15, the title of that. Then I'm going to giving here plt.imshow this word cloud. So this word cloud actually help you, these functions actually help you to show you word cloud. Then I'm going to using here plt.axis. Let's try to making this axis should be off. Okay, we don't need to printing here the axis. Okay, now what I can do is simply going to creating here the word cloud. So you have to creating the word cloud. You know, to also taking the list of your classes, that how many classes are available. So for that I'm going to creating here one variable called the emotions list. That's actually giving here all of the emotions list. So we can take it from our train data. So let's say train data, and we have the emotions inside the emotions. So for taking the classes, we can actually using here the unique, so that it actually give me unique types of values. So that means 6 types of classes it will give me in the list. Now what I can do, I'm simply going to iterate to all the emotions in our emotion list. Okay, so emotion list, And from the emotion list, what I can do, I am simply first taking all the text. I mean these taxes, this text from our comment. So what I can do, I am simply going to creating here the join method. So let's say empty, then join method, and taking all of the value from our train data. So let's say train data dot log, and just creating here a log. And after creating the log, we will be getting all of the data from our comment, from our emotions. And now based on the emotions, we're going to checking for the comment. So the emotion is coming up here. Emotions is coming up here. Now based on the emotions, we're going to take, we're going to taking the comment, this comment. Then after that, what I can do, I am simply going to lock it. Yeah, lock it here, lock it here. And also I need to creating here on list comprehensions. For that, I need to also taking this data in my sentence. So let's say for sentences in, okay, for sentence in strain data log, I simply going to checking for the emotion data, emotions, that which kind of emotion is it. If it just matches this one emotions, then we're going to taking this comment and pass it inside just like a sentence. Now the sentence is passing to the list comprehension, so that's why we not to also return it like this way. Okay, sentences, sentence. Okay, now we need to pass it inside the list comprehension, so I need to giving here like this way. Okay, now it will give me all of the data based on the emotions. Now this is our text. Okay, well, so now based on the text, what I can do, we're simply going to creating here one word cloud. Okay, so for generating the word cloud, you can using here the word cloud that we actually import earlier. And inside this word cloud, I need to giving here the width and the height. So let's say width is nothing but call 600, and also the height, that's giving here 600. Then after that, I need to using here the dot generate, so that it can generate the word cloud. Okay, it can generate the word cloud based on my text, okay, that I pass. Now let us store it inside the variable called the word cloud. So word cloud, that's it, that's it. Now what I can do, I am simply going to using this word cloud inside this my functions that I actually created. So word cloud, and I'm going to passing here the word cloud, this word cloud, and after that I'm going to using here the emotions. Now shift enter, and let's try to check that what kind of word cloud it's created. Okay, it will take few times. You can see sadness word cloud. Okay, sadness word cloud. Okay, we don't actually giving here space, so that's why this space is not showing up. This is word cloud for the sadness. This is the word cloud for the anger. Word cloud for the love. Word cloud for the surprise. The fear word. The joy word. Okay, well, so you can also adding here one space on that, so that you can getting here some space. Okay, this is how actually creating here the word cloud, and also just having look of your data, that how your data set look like. Okay, now what I can do, we simply going to applying here the machine learning algorithm, but before that, I need to also do the data preprocessing. Just you need to actually encoding here the emotions, because this is nothing but textual data that you can see, sadness, the anger, the love, like this way. This is nothing but in the text, so you need to convert them into categorical. No, not categorical, into numericals, just like a 1 2 3 4 like this way. So for that, what I can do, actually using here the feature encoding, or you can use here the N11 encoder also. So I'm simply going to using here the LB and call the level encoder, but it's better you can take one shell and try to check that. Try to write here data pre-processing. Okay, well, so let's creating here the level encoder, and creating here an instance of the level encoder. Now I'm simply going to use it inside my data. So train underscore data, and I'm going to using here inside our emotions, and from the emotion I'm going to using the lb dot fit transform. Okay, transform, and inside this fit transform I'm going to passing here my train data, and inside this train data I'm going to passing here my emotions. Okay, that's how the emotion is created. Okay, now if I shift enter and try to checking your training data dot head, now you can see it's converted into just 0 1 2 3 4 like that. That's mean it is converted your categorical data into the numerical. Now you can simply feed it inside your machine learning algorithms. So now you can see we just actually importing here some machine learning packages, but we don't actually importing here the machine learning algorithms. So what we need to do, actually we need to also loading here our machine learning algorithms, just like the logistic regressions or the naive Bayes algorithms. Just going to actually import it, all of the things. So now what I can do, I'm simply going to import it, let's say from sklearn dot model selections, and then I'm going to importing here the train, test, and split. So train, test, and split. Then we having the count vectorizer and also the TF IDF vectorizers. So what I can do, we can import it also. So let's say from sklearn dot feature extractions dot text, and I'm going to importing here the count vectorizers, and then TF-IDF vectorizers, then from sklearn dot naive Bayes, and I'm going to importing here the multinomial ND because this is the multi-class classification tags, so that's why. So from sklearn dot linear model, I'm going to importing here the logistic regressions, then from sklearn dot ensemble, I'm going to importing here the random forest classifier. So random forest classifier, then I'm going to also import the SBC. So from sklearn dot SBM, I'm going to importing here the SBC. Then I'm also importing here the accuracy score and also the classification report. So from sklearn dot matrices, and I'm going to importing here the accuracy score, then also the classification report. That's it. Okay, we import all the things. Now what we can do is simply going to taking the copy that we do earlier, also taking one copy when creating here the distribution of our data set. So we now let's taking also one copy from that, because we're going to using here also the deep learning just like the LSTM. So that's why it's also taking the copy for that. So df equal to train data dot copy, just taking one copy for that. Now if you try to checking this one, df dot hat, and that you can see this our copy of our data, but our train data dot underscore data is as it is. Okay, we're going to change this the data in our df. Okay, so now what I can do is simply going to just cleaning our comment for the data cleaning. Okay, we're going to using here the NLTK. So for that, what I can do, I am simply going to using here the NLTK, but we already imported here this NLTK library before, but you need to also downloading here the stopwords. So for that, we're going to using here NLTK dot download. Actually, you need to downloading here the English stopwords. So we need to using here stopwords. Okay. Then after that, I'm also using here the stopwords. Stopwords equal to set NLTK dot corpus. Okay, corpus dot stopwords dot words dot word, and inside that I need to using here the English word. Okay, English. Okay, the stopword is nothing but English stopword. So NLTK dot corpus dot stopwords dot words is nothing but English. That's our stopword. Also try to importing here the TQDM, so that you can see the progress that when you try to actually building this comment in passing inside our port streamer, or try to remove the stopword, so that you can see the progress. So let's say from TQDM, we're simply going to importing here the TQDM. Okay, TQDM. So simply going to using his TQDM inside our pandas data frame. So that's why we're using the pandas, especially for the pandas. Well, so we have the NLTK.download stopwords. We download here the stopwords, and also creating here the list of the stopwords here. So now what I can do, I am simply going to creating here one function which will help me to clean your textual data, because there are some noisy data also. You need to remove the stopwords or this ampersand like this way, and to actually remove all of the things so that it will fitting for your machine learning model and also for the deep learning model. So what I can do, I am simply going to using here the clean data, just creating here one functions, clean data, and going to passing here the text. So first, what I can do is simply going to creating here a streamer. Okay, streamer. So using the portal streamer that we actually imported earlier. this sporty streamer, I'm simply going to use it. And after that, I'm simply going to using here the regular expressions that we also import it here. That you can see import RE. Now I am simply going to removing all of the regular expressions from our dataset. So for that, I'm using here re.sub, and inside that I need to using here this double quotations, and inside this double quotation I need to using here this tube sign. So where is this tube sign? Yep, tube sign, this one, and having a okay, then a then to Z, and from capital A to the capital Z. Okay, then we simply going to remove it and try to fill it with the empty string and try to passing him a text. So that's our regular expression. So it will go from the small a to the small z and capital A to the capital Z and try to fill it with the empty string. Now let's make it text. Now I am simply going to convert this text into the lowercase letter. Okay, don't have any so that it don't have any uppercase letter. Then I'm going to split it, text. So text or split, if it is getting the space, it will try to split it, and after that you need to pass it inside my streamer. So for the streamer, I'm simply going to creating here one list comprehension. So let's say for word in text, if word not in stopword. Okay, if not is stop, it's if the word is not available inside the stopwords. If the word is not available inside the stopword, we're going to taking this word from our text, and after that you're going to pass it inside my streamer. Okay, streamer dot stream, and inside that I'm going to passing here my word. Okay, let's have a look again. If the word is not available inside the stopword, we're taking this word from our text. Okay, from our text we're taking the word. If the word is not available inside the stopwords, then we passing this word inside our streamer, and this stream word is taking processing, and after that we actually trying to pass it inside the text, and after that we simply going to return it. Okay, return it and try to join this with the empty string dot join, and after that I'm going to passing my text. So that's our clean data functions. So now what I can do, I am simply going to creating here one extra column. So let's call that clean data, clean it comment like that, and then I'm going to using here the df of comment. Okay, df comment, and after that I'm going to using here this dot apply. But here one thing, so when actually using here the tqdm, when actually using the tqdm, in order to get in the progress, you can't using here the apply. You can't using here the apply. You need to using here the progress apply. So progress apply. Okay, then you're going to passing here this clean data functions. Okay, if you are not using here this tqdm, you can simply using here the apply. So let's try to copy this out and also paste it out here, so that if you are not interested to using here the tqdm, you can actually using his apply one. Okay, that's it. Shift enter. Okay, tqdm is not defined. So from tqdm we import here the tqdm, but why it is told me that okay tqdm that mistake you hota hai bhai. Okay, now you can see, you can also see the progress. Okay, but when you're not actually importing the tqdm, just you can see here one star sign. Okay, so this is how your data set is actually cleaned. So now if you try to checking this one df.head, then you can see here an extra column that's called the clean data, I mean clean comment. So in the clean comment, you can see it removing all of the stopwords and also using the portrait streamer. So portrait streamer is nothing but for if the word is nothing but similars, just like the beautiful and the beauty are mostly similar. So it will try to creating this two word in a one single word, just like you can see humiliated to the humili. Okay, and also the is actually remove this icon also. Go feel so hopeless, it also remove this. So then it try to making this hopeless should be the hope. Okay, because hopeless and the hopeless and hope is also the same meaning in the NLP. So that's why it actually removing this all of the streamer and try to creating here an extra column that's called the cleaned comment. Well, fine, now it's ready. It's ready, our data is ready. So now what I can do is simply going to divide our data set into train, test, and split. So for that we're going to using here this train data uh, passing this train data instead of a train test split. So let's say train test and split, and after that I'm going to passing him a df of clean data, I mean clean comment. So clean comment, and then for the y I'm going to passing here my emotions. So emotions. Then after that I'm going to giving him a test size. So test size, let's giving here 0.2, and the random state 42. Okay, so this should be the x train, the x test, y train, and the y test. That's it. So our data is right now divided into training and testing. So now what I can do is simply going to use here the TF idea vectorizers, and then we are going to import, you are actually applying here the machine learning algorithms. Well, so let's try to also creating here the TF idea vectorizers. So TF idea vectorizers, just getting here on instance of that, and you can also using here the count vectorizer also. So that's a TF IDF vectorizers. Okay, vectorizers. Okay, then what I can do, I am simply going to using here this TF IDF vectorizer in our training data for the X train and also the X test. So we simply going to using here this TF IDF vectorizer dot fit transforms in our X train data. Then we need to do the same thing for the testing data also, but without using fit. So X test data. Now we need to also using here this one. It's called X train underscore TFIDF, like this way, and also this one should be the X test TFIDF. Okay, shift enter. Okay, IDF is not defined. TFIDF. Yep, here they are. Okay, now you can see it's our data set is converted into the TF-IDF vectorizer. If I try to check this one, just having looking at your data, this is one sparse matrix. Okay, if I try to checking the shape of your data, how your data shape is look like. Okay, so now what I can do is simply going to apply here the machine learning algorithm and try to classify this one. Well, so now what I'm gonna do, I am simply going to creating here one dictionary for the classifier, because this is a classification task. So what kind of model we have? We have the naive Bayes algorithm, I mean the multinomial NB, then have the loss regression, the random forest classifier, and also the SBC. So what I can do, I'm simply going to creating here one dictionary for that. So let's say classifier, and after that we're simply going to creating here one dictionary and using here this multinomial NB. Okay, then I'm going to give it here one name, so that key value pair should be here. The first thing is nothing but the name, and this is nothing but my instance of the classifier. Then I can using here one for loop and iterate to all the value from here and try to creating here one feed function, and we can actually using here this logistic regression and also the all the classifier that I can actually use. Okay, so now I'm going to using here creating the instance of the all of the model that I initialize here. So now the fourth point is nothing but called the random forest. So random forest. Okay, and going to creating here the random forest classifier. Then we have the support vector, support vector, support vector machine. After that we have the SBC. Now we can simply going to iterate to all the classifier list from here. So what I can do, we can simply using here for name and also the classifier in classifier dot items. Okay, items, and after that it will give me the name and the classifier. So name is nothing but my machine learning model name, and CLF is nothing but my instance of the classifier. So using this instance we can actually fit our model. So that's why you can using here CLF dot fit, and inside this fit we can using here the RX underscore train and Y underscore train. That's it. So to give me in the predictions value, I mean for the classifier. So what I can do, we can also printing like that. Let's print the model name. So we can using here one f string, and after that I can using here the f string, then using here the name, and after that we can actually using here this kind of uh, things. Okay, so you can also using here one backslash n, so that is look better, just like multinomial LB, the support vector machines, the logistic regressions, it will actually showing up. Now we can using here uh, we can using here the predict function in order to getting the predictions. But you can see this is the x train and the y train, but we need to passing here this x train tfidf, this x train tidf here, because in the form of the vectorizer you need to pass it here, but we don't need to do this for the y train. And now we can using here this classifier dot predict, and inside this predict functions I can using here my x test. Okay, x test tfidf, x test tfidf, and after that I can using here for the predictions I can using here x test tfidf, and it will give me the prediction for the y prediction for the tfidf idf. That's it. Okay, so this is the prediction value. So now we can also checking for the accuracy score also. So inside this accuracy score I'm going to passing here my y test. Okay, this y test, and also need to passing here this y prediction tfidf for the accuracy score. So to give me the accuracy score, so what I can do, you can using here accuracy tfidf. Okay, then after that we can simply going to print it out. So print, and you're going to using here this accuracy tfidf. So let's say like this way. Okay, we can using here this accuracy tfidf, and we need to using here this f string here also. So you can copy this out and we can pass it here, and we can using this one. Okay, fine. Now what I can do, this is for the tfidf accuracy, and also you can printing here the classification report. So what I can do, we can give here one print function, so let's call the classification report. That's it. And after that you can actually passing using here the same things for printing the classification report. So let's try to print it out here, and we can using here the classification report, and inside this report you can passing here my x test, sorry, y test, and y prediction tfidf. So I'm going to copy this out and I'm going to paste it here, and I'm going to run this one. Okay, you can see here this is a classification report. The accuracy is nothing but 0.655 for the multinomial NB, it's called the near bias algorithms. And for the logistic regression we got here 82% accuracy, and for random forest it will generating, and because it will fitting with the model, and it will give me the accuracy score and also the classification report. So if I see the report of the logistic regression is not so bad, we got here 83% accuracy, and precision recall f1 score is also good. So it will also doing it for the random forest, and after that it can do it for the sbc also. Okay, that we actually declare on here. So this is how the machine learning model actually work. Now from this above model, what I can do, we can select here the best model, and which model actually give me the best accuracy. So then we can actually using here the instance for that. Okay, so let's check this one. It will obviously take time, the classifier take times. Okay, but before that we can actually creating here one predictive model, which can actually give me the predictions that how you actually behaving here on input text, and it will give you the predictions. So what I can do, you can simply going to creating here one function for that. Okay, for random forest we got here 85% accuracy. Now let's wait for the support vector machines, but okay, let's creating here the function which can actually help us to predict the emotions. Let's call the predict emotion, emotion, and inside this emotion we're going to passing here my input text. Okay, input text, and inside this input text we need to cleaning this input text that we do earlier here. So we need to call this clean text, I mean the clean data. Okay, if I see we already creating here this clean data functions, so we're going to copy this one. Let's call it clean data, and inside this clean data I'm going to passing here my input text, this input text, and this is my thing by my clean text. So clean text. Okay, this is my clean text. Support vector machine is actually taking time. Okay, it's also generated. So for this cases we see that random forest give me the best accuracy in terms of logistic regressions, that is see 82% accuracy, and inside that you can see precision is nothing but 88%. Recall, okay, recall is loss, 85% accuracy for the random forest. So you can select here the random forest. So what I can do, we can use it here the random forest. So let's say call uh, let's select the logistic regressions. It's your homework to do it the random forest. Your homework to do the same thing, do this work using homework. Your homework is do the same thing using the random forest. Okay, random forest. It's your duty. I mean, it's your homework to try it with the random forest. I'm going to go for the logistic regressions. It's also the accuracy is nothing but 83%, quite good. So let's try to initialize here the logistic regressions. And inside that, I'm going to using here lg.fit, and inside this fit, I'm going to using here xtrain, x underscore train, tfidf, tfidf, and also my y train data. And after that, we have the predictions for the logistic regression. So let's call lg.predict, and inside that, we can using here the xtest, tfidf, and it will give me some predictions value. So let's call lg, let's call y predictions, prediction, this one. Okay, having some error on here. So let's input variable will consist of the sample here, xtest tfidf. Oh, that should be the xtrain. Okay, that's why this error. So xtrain. Okay, and for the testing one, we can actually using here this one. Okay, we got here the prediction value for the logistic regression. So now what I can do is simply going to using this model and try to predicting here the emotions of the text of the comment. Now what I can do, we can using here this tf idea vectorizers, dot transform. We simply going to using here this transform and try to passing here my clean text, this clean text. So clean text, this one, and this clean text is now converted into the tf idea vectorizer that you do earlier in the machine learning concept also. Then it will give me the input vectorizers. It give me the input vectorizer. Okay, input vectorizers, that's it. Now we need to predict here the emotions. Okay, so for predicting the emotions, we can using here these logistic regressions. You can also using here the random forest. Then you could be passing here my input vectorizers, this input vectorizer, and with the instance of 0, so that it can give me 0 1 2 like that. So this is nothing but a prediction. So it's my predicted label. Okay, it's my predicted labels. Now I need to for getting this inverse transform, we can actually get here the predictions name. So in order to do that, you can using this inverse method. So let's call lb. Okay, lb dot inverse. Okay, inverse transforms. Okay, inverse transform, and inside that we can passing here my passing my predicted labels. So that's my predicted labels, and getting this first value from that. Okay, it will give me the predicted emotion. I mean, which kind of emotion is it? Is it love or joy, like that? So predicted emotion, predicting emotions, and in order to getting this label, we can using here the np.argmax. So np.argmax, and inside this argmax, you can also using here the max. Okay, or otherwise you can also using here the argmax. Let's try to using here the max, and then we can using here lg.predict, and you're going to passing here this input vectorizers. Okay, vectorizers, this input vectorizers. Now what I can do is simply going to returning in here one predicted emotions and also the labels. This label actually give me the label, which kind of label is detected, and prediction emotion is actually give me the values. That's it. So our predicted emotions is ready. This function is ready. So we can using his predict emotions functions and try to test it out here. Now let's giving here one sentence. So let's say he hates you. Okay, and this main functions. Okay, predict emotions. Okay, okay, it's actually return me here this one. It's called predicted emotions. I need to using it here. Okay, now you can see it's called anger. He hates you. It's nothing but also anger. Sometimes he's angry. Someone, your girlfriend maybe said that, hey, I hate you, like this one. So this is nothing but anger, the anger issue of the female. Okay, so this is how you can actually getting here the emotions of your value. So now let's try it another one for the data. So what I can do, we can simply going to copy one from here. I did not feel the humidity this one. Let's try to using this one. Okay, that's it. And you can see here this is called the sadness. Okay, this is how it is actually really work. Yes, I didn't feel the humidity. Okay, So let's say she break up with me. Okay, break up with me. So this sadness, obviously sadness, क्योंकि breakup set होता है. Okay, that's fine. Now you see that how your machine learning algorithm actually work and try to predict your emotions. Now you can also using here the deep learning to predicting the emotions of the person or the text or the comment box. So what I can do is simply going to first saving all of the files and applying here the deep learning models like just like the LSTM. So for the saving, we're going to using here the pickle. So for pickle, we're going to put here pickle, and after that I'm going to using here pickle dot dump, and inside is dump I'm going to passing here my model name that's called the LG, and after that I'm going to passing here an open method, and inside this open method I'm going to using here my model. It's called logistic regression dot pickle file, and inside that I'm going to passing here my WB. So it's called a WB. That's my pickle file. I'm going to save it here, and I'm going to copy this one, and I'm going to pass it here, pass it here. So inside this is called the LB. LB is nothing but my level encoder. I mean, which kind of level? Sorry, who need to using the level encoder for that. You know, to actually converting your data into the categorical to the numerical. So what I can do, you can using here the label encoder. So label encoder dot pickle file, and inside this pickle format, you can actually using here the dump, and you need to also store here the TF-IDF vector results when you try to testing out here in another MacBook or another Windows or the another Linux system. You need to actually using here these files. So for that, I'm going to using his TF-IDF vectorizers. Vectorizer is also needed. Then we need to also give here one name that's called TF-IDF vectorizer. Just going to copy this one and going to pass it here, TF-IDF vectorizers. That's it. So shift enter, it will saving all the file inside your directory. If I see that, you can see the level encoder.pickle file, the logistic regressions, and also the TF-IDF vectorizers. Now when you try to building here on machine learning applications using Flux, so we can actually using this one and try to creating this application like that. Okay, now what I can do, we simply going to apply here the deep learning algorithm, just like the LSTM, also called the long short term memory. So called applying deep learning using LSTM. That's called the long short term memory. Okay, memory. That's called the long short term memory. That's called the deep learning methods. So now what I can do, we simply going to first going to creating here the text clean functions, but yet we already do it out this clean data. Yeah, that's also same, but here one problem in the deep learning when you try to using here this clean data, if you can see, just to wait, how I did it. I think it's up here. Yep, clean data. In this clean data, we see that we just using here the portrait streamer and using here the regular expression here to actually remove all the regular expressions and also the stop word. But when you actually applying here the deep learning, you need to using here the portrait streamer also, and also you need to pass it inside your one hot encoding part, and also you need to pass it inside your path sequence, because you need to pass it inside your LSTM model. That's a deep learning model. Path sequence is nothing but reshaping your data. That's mean when you actually using this clean data method, it not work. That's mean the clean data things is obviously same, but you need to do two starting. That's called the one hot word or one hot encoding, and also called the path sequence. Now after that, we can get here on pad, and we can simply going to pass this pad inside my LSTM model. That's the thing. So now what I can do is simply going to creating here one text cleaning functions for my deep learning model, and after that we can pass this data inside my LSTM model. Well, so now what I can do, I am simply going to creating here the function that's called the text cleaning, okay, that we're discussing. Okay, and this text clean actually taking some parameter that's called the df. This is my data frame, then also having a column, which kind of column I'm going to taking. Then after that, I need to also giving here on vocabulary size, that's called the vocab size. Okay, vocab size. Then also the max length. It's nothing but called the maximum length. How many length of vocabulary or the sentence or the word are you going to pass it inside your LSTM model, right? Then you need to using here the streamer. Okay, I need to apply, I need to just creating here the steamer, or it's called the portrait steamer. Then after that I need to creating here one empty corpus list, so it's called corpus, empty corpus, and here actually going to store all the pre-processed text and try to pass it inside the one hot encoding. So the column is nothing but for iterating all the value from the data frame, so that's why. So for text in df of columns, so columns, okay, this column I'm going to pass it here, and after that we can guarding here all the things that you see. So what I can do, we can simply going to copy this from here, just going to copy this out, these things, okay, these things we can simply copy this out. Okay, so we can simply going to paste it out here. Okay, so there's our text, that's our text, that's our text, that's our text, and also that's our text. That's mean our regular expression is also working, and we also checking for the stopwords and also for the streaming. And after that we can also join this one. So let's say text equal to this one, and dot join, and inside this join method I'm going to pass in here my text. Now I can simply going to pass in this text, this preprocessed text inside my corpus. So I can using here the append and passing here this text. Now I need to using here this one hot encoding part here, so I'll call one hot word. Okay, let's call one hot word for each of the words. Then I can creating here one things, just creating here one creating here one list comprehension and passing here this one hot. If you see, you already imported it. Okay, if I see, that's called one hot. Okay, if I see, yep, you can see here one hot, you already import it here. Okay, so we can using it here. So one hot, and inside this one hot I can passing here my input text. So input text is nothing but my word, input text is nothing but what, and number, how many number I'm going to passing here, it's nothing but the vocabulary size. And after that we can simply going to passing here this what, which one is iterated to from our stopword. Okay, from our stopword. So what in text, what in text, if what, okay, what not in stopword. Again, see, this is the same thing. If the word in the text from the text is not available in the stopwords, we're simply going to pass it inside my one hot encoding. My one hot encoding. So input text in the word and number of vocabulary sizes here, and what inside this text. That's it. That's it. Now we need to pass it inside my pat sequences. My pat sequences. Now which kind of sequence we're going to pass? Which kind of sequence we're going to pass? We're going to passing here this one hot encoding. One hot encoding word is nothing but one sequence. Okay, one hot word. Then after that I'm giving here the maximum length, I mean maximum length of the word. So maximum length is nothing but is coming from here, max length, and also the padding. Okay, padding we can give here the pre, okay, for the prefix. Then we're simply going to return here our pad. So return here our pad. So let's revise it again. So initialize here the steamer and also corpus. Then after that we can get in here all the columns. I mean which column I'm going to take it out. Let's say comment columns. Then regular expressions, the lower letter splitting, using here the steamer, then join, and after that you can pass it inside the corpus. Then after that you're using here this one hot encoding. So one hot input text is nothing but a word. The number of vocabulary size it is taking is coming from my corpus. Okay, I don't think that this word is necessary here, because you already do this stopword here, this stopword in our steamer. So we don't need to using this one. Okay, what in the word should be not in the text, the word should be inside my corpus. Okay, corpus. That's kind of mistake we can do that. Okay, the word in the corpus. Now you're going to pass it inside by one hot word variables. That's good. That's good. Now what I can do, I simply going to cleaning this one. So shift enter, and now we can using here the text cleaning, this text cleaning method, and inside that I'm going to passing here my training data. Okay, training data. Now you can see why I'm taking this copy of that. Now training data, and now I need to using here my column. So column is nothing but my command, and then after I need to giving here my vocabulary size is nothing but 11000, 11,000, and maximum length let's giving here 300. Okay, you can give it for the vocabulary size, how many vocabulary is available inside one 300 of the text, you can know. I just taking it here, just hit and trial. Okay, you can also increase this one. Okay, now for the white train, this is my X train data. Okay, and now I want to also initialize here the white train. okay, white train. So I need to convert this into categorical, okay, to categorical. So passing here the train underscore data, and inside that I'm going to passing here my emotions, okay, passing here my emotions, okay, emotion, okay, that's it. So X train and Y train data is ready. So it will taking times because it is converting it here. Okay, let's take down. We got one error. Name pad is not defined. It's called a pad sequence, so that should be the uh, pad. Okay, that's it. Okay, now it will try to creating here the 100 encoded. After that, it will creating the sequence. Well, now our the task is ready. Now we can actually creating here our models. Okay, so what kind of model are we going to be building here? We're going to be building here the sequential types of models. So for that, I'm going to be using here model. So that's a model. Oh, थोड़ा speed हो रहा है. Model is nothing but the sequential model. Sequential model. That's a sequential model. So what I can do now, you're going to first adding here our input layer, and when you're creating here one input layer in the LSTM in the terms of the NLP, you need to using here one embedding layer. While you're going to passing here your input dimensions. So our input dimension is nothing but 11,000. So we can using here model dot add, and inside this add we can passing here this embedding layer. Okay, embedding layer, and inside this embedding I'm going to passing here my input dimensions. So input dimensions, and input dimension is 11000. Okay, and output dimension is nothing but let's call output dimensions. Output dimension is nothing but 150 is 150 on my input dimensions, output dimensions, and input length is nothing but 300. That's my maximum length. So maximum length is nothing but input length. I mean how many length of value I can put it down. Okay, then after input dimension should be the 150 greater, output dimension is 150 greater, I know. Okay, that's our embedding layer. Now we can actually adding here one dropout layer. So model dot add, and after that you can using here one dropout in order to just overcome these overfitting problems. So dropout, let's say 20% of the neuron should be deactivated, and we're going to be using here one LSTM model. So let's call add, just add here LSTM layer, and going to passing here 128 neuron for the LSTM, and simply I'm going to be using here another dropout. Okay, then I'm going to be using here my dance layer. So let's call model dot add, and inside I'm going to be using here the dance layer, and inside this dance I'm going to be using here 64 dance layer, and activations. Activation is nothing but my sigmoid activation functions, and again add one dropout layer. Okay, and after that I'm going to be using here the same sigmoid to the softmax. Okay, to the softmax. Okay, and after that I'm going to compile our model. So let's call model dot compile, and inside that I'm going to be passing here my optimizers. So optimizers, and optimizer is nothing but called Adam. Okay, and inside that I'm going to passing here my loss is nothing but called the categorical cross entropy, cross entropy, and TROPY entropy. And after that the matrices, and I'm going to passing here my accuracy matrix. Okay, that's it. Now we can do training this one, but before training you also using here the callbacks. So let's use here the callbacks. Okay, callback equal to early stopping. Okay, early stopping, and inside is monitoring. So inside this monitor I'm simply going to monitoring my validation loss because loss is needed. And after that for the patience is nothing but 2. Is that after 2 times the validation loss is not improved, it will automatically stopping these executions, right? Then we're going to using here the restore best weight should be the true, and our callback is ready. Well, now you can using here the model.fit, and after that we can using here the xtrain. Okay, xtrain, and also the white train, and after that again using here the epochs. Okay, epochs, let's giving here one right now because I will train this model with the tiny epochs. You can get this model file in my GitHub repository. You can just get this out and try to create in the web applications. Yes, now the question is which kind of model I'm going to using here to creating the web application. I'm going to using here the machine learning model. It's your homework to do these things using deep learning. Yes, I'm also provide you the code of the model. Just you need to improve it. Okay, just you have to think that yes, you are working on that. Okay, now let's giving here the batch size. Batch size. Okay, so batch size is nothing but how many size of the images or size of the vocabulary you're actually passing. Okay, so let's giving here 64, but it's depend on the capability of your machines. In my case 64 is okay, but if it is not working on your case, let's say if you have CPU, you can give it here 16 or 32. It's based on your laptop, but don't take the risks. Otherwise your laptop or the PC, whatever else you are using, it should be destroyed. Okay, that's the verbose. It's nothing but call one, and inside is callbacks. Okay, callbacks, and I'm going to passing here my callback. This callback this one. Okay, how actually shift enter and starting. Okay, again error. Okay, what kind of error? Shape 64.6 and 64.6 are incompatible. Let's see what kind of error you got. Okay. It's 64. It should be the 6 because this is the last layer. Now you can see one thing. You can using here. We use here the softmax. Now the question is why should not using the sigmoid? Why should not using the sigmoid? Because this is a multi-class classification problem. It's having more than two classes, and also we need to passing this data inside the two categorical. That's why we actually passing here this loss should be the categorical cross entropy. That's the thing. Shift enter down. Okay, let's see that we got here error. No, we don't get any error. So it will take 3 minutes to actually training this model. Yes, I training this model the tiny box and I got here 97% accuracy. Yep, 97% accuracy I got. So I'll provide you the model. I provided the model. Just using this model and try to creating the applications, the Flux application, because I'll do it using this logistic regression model. It's your homework to do the same thing, using the logistic regressions. And better you can join our Discord channels, and you can also giving here the screenshot. Just join our Discord server. I will available here every time. You can just go on the machine learning channels. Okay, machine learning channels, and you can post your answer. I mean, you can post your result that, sir, yes, I do it, and after that 10 bucks I got here 97% accuracy, and that's our model using the deep learning, and I also creating this kind of applications, and it's really working fine. That's kind of thing you can also pass inside my Discord server. Well, now after that, what I can do, we can simply going to creating here one predictive system using this one, because we're creating the predictive systems using the logic regressions. Now we're also creating here on predictive systems for the deep learning also. So for that, what I can do, I am going to creating it out. That's a def. Let's go to def and giving here our name called predictive system for DL. Okay. Now this is nothing but taking one sentence. Okay, sentence. Okay, or you can say the text. Now inside that, what I can do, I simply going to doing the same thing, doing all the things, just like the cleaning, text cleaning. So I am simply going to copy this one. This is steamer and also the corpus. So it's steamer and the corpus, and also this text, this regular expressions, and I'm going to pass it here. This text. Okay, and I need to passing this sentence instead of text, and to passing here this sentence. Okay, now you can make it as a text also. Okay, after joining them, so what I can do, I can using here the corpus.append that you do here, corpus.append, and after that I need to also pass it inside my one hot encoding. So we can copy this one also. Okay, just copy this one hot watt encoding, and also the pat sequence. So one hot watt is nothing but one hot. The input text is nothing but the word, and number of vocabulary size should be the 1100. Okay, it's predefined. It's from the corpus. Now the pat sequence is okay. Maximum length is nothing but 300. Okay, and padding is nothing but pre. Okay, now we can simply going to return here the pat. Well, okay, so what I can do now, I don't think that it will give me the best answers. No problem. I'll actually putting here the code, this model file inside my directory. Then we can actually run this predictive system DL. Okay, that's it's ready. Now what I can do, we can actually using here this cleaning method in our sentences. I mean this one, and after that getting this data from here, and we can actually using here the predictions. So let's give in some times. It will actually predict this model. I mean training these models. Then I will back again how it is actually completed, because I need to also passing here this model file for the tiny box also inside my same working directory. Well, so after one epochs, I got here 39% accuracy. So how can you actually save in this model? So we can using here this model dot save. So model dot save save, and inside that I can passing here one name. Let's call model dot ace5 like this way. So it will save it this model dot ace5 inside your directory. So if you see, just to wait, you can see here model dot ace5, and also you can see here model1.ace5. That's my previous file, just actually do for 10 epochs, and I got here 97% accuracy. So what I can do, I'm simply going to using this model1.ace5 file also. Yep, you can using here this model1 also. Okay, this model. Okay, so let's try to do this one, then we can load it yet. Okay, so these were pat sequences. Now what I can do, we can going to test it out. For testing, we can using here this predictive system DL, and inside that you're going to passing here one sentence. Let's say he hates me. He hates me, like this way, and now it will give me one sentence. Okay, now I have to using here the same inverse things that you do here for the transformations. I mean for getting here the machine learning also. So just invert transforms, and this one, and I need to using here this invert transform, and inside that I need to passing here one thing that's called np dot argmax, and inside this argmax I'm using here the model dot predict, and inside that I'm going to passing here my sentence. Okay, and inside this axis I need to using here the axis should be the one. Okay, that's my axis, and inside the 0 I mean for the columns. Okay, now that's about inverse transform, and that's about results. So let's using here the result. Okay, result. Okay, now we can pass these things inside my np.max, and now I'm using here the model. So model dot predict our sentence. Okay, sentence. Okay, that's our sentences. So the sentence is nothing but our, it actually give me the probability. So probability, and this result is nothing but my results. So we can using his print statement and try to using here the f string. Okay, f string idhar yes karna hai. Okay, then it's our result with probability of proof. Okay, let's see. So it's sadness with the probability of 0.54. Yeah, sadness, I know it's working fine. Now let's start using here my one. Okay, that actually uh, um, train it for the tiny box. Let's say from Keras dot models, and I'm going to import here the load model, called the load model, and that's our model now. So that's called model number 01. It's nothing but called load model, load of model, and passing here my model 1.ace5. That's it. Okay, model 01. So let's start using this one. Model 01 predictive and predictive, like this one. Okay, you can see sadness is a 60% probability. Quite good, quite good, quite good. So let's say I'm filling okay, feeling love with you. Okay, 41% accuracy the joy. Yes. Okay. Okay, प्यार वार मुझे नहीं होता, प्रोग्रामर से प्यार नहीं होता. Okay, so this is how your system actually work. Now you can save it. Okay, that's the thing, that how can actually creating here this creating these applications with the machine learning and also the deep learning. Now we can also save here our vocabulary size, because we also passing here our vocabulary size. So not also saving this one. So what I can do, we can simply going to using here the our the level encoder and also the vocabulary size also, because for the deep learning. So what I can do, we can using here this with open, and for the level encoder, so I can using here the lb1, okay, dot pickle format, pickle, okay, in the form of a wb, okay, as f. Then after that I can using here the pickle dot dump, and inside is dump I'm going to using here the lb and also the f. Okay, lb is nothing but for the level encoder. It will dumping inside my directory. Then it also using save the vocabulary. So this vocabulary having some informations, just like we can pass it inside one a dictionary. So it's called a vocab size. So vocab size is nothing but called 11000. Then after that we can using here the max len. So max underscore len is nothing but called 300. Okay, so we can using here this as a vocab, okay, vocab info. So how you try to actually using here this deep learning method, try to creating these applications, you need to also record this vocabulary size and also the level encoder also. That's why I also do this one. Okay, so it open, and I'm going to using here this vocab, okay, vocab info. You can get all the file in your GitHub, in our GitHub repository. You can just go on here and grab the code from here. Okay, otherwise you can also try this one. Okay, wbsf. Then I'm using here this pickle dot dump, and inside that I'm going to passing here this vocab info and also my f. Okay, that's ready. So you can now check this one, this lv1, this model 1.is5, and also the vocab info.pickle file. So don't worry, all the files should be the less than 25 MB. So you can pass this file inside the GitHub repository. You can grab the code from here and try to testing it out. Now what I can do is simply going to creating here the web applications using machine learning one, using a machine learning algorithms. Yes, it's your homework to do the same thing using deep learning, using the deep learning. Okay, using the deep learning, and try to upload your result in our Discord server. In the machine learning options, you can pass, you actually put it down. Sir, I am doing this one, that's my result, that's my this one, that's my this one. If you're facing any problem, just comment below. I'll try to giving you the response. Okay, now let's try to creating here the web applications using the Flux. Well, so this is the code for that, and I also already opened this code in my BS code. This is called the app.py. Inside this code, we're just creating here our API. And also you can see here a folder that's called the templates, and inside this template folder we have the index.html, which one I'm going to rendering here. Okay, so let's try to checking this one, that how what actually happening inside this index.html. So inside this index.html we have a title that's called the emotion classification using LSTM and the machine learning, and also having some style code for the CSS. Then we having one form. This is the main thing. This is called the form. So inside this form, you can see here enter your comment, and also one button for submissions that's called the analyze. Okay. Now inside this form, we have one h1 tag that's called the emotion classifications. Then we have one from, and inside this from you can see here the method is nothing but called a post method. Post method is nothing but when you're trying to giving here an input and try to getting the results. And also there is another method that's called a get method. When you're trying to get in the data from your database, that's called the get method. That's mean if you are trying to put your data and try to getting one predictive model value, it's nothing but called the post method. Well, now you can see here this is the actions, and action is nothing but called the URL for analyze emotions. So analyze emotion is nothing but my functions in my app.py. If I go inside this app.py, you can see here a function, or you can see the method is called the analyze emotions in my route. Okay, this is also one route. That's been when you are trying to using one our comment. I'm just going to filling with our comment, and when I clicking this analyze button, this submission button, it will calling this analyze emotion route. This analyze emotion route actually helps me to getting the value of my sentiment, of my emotion, okay, of my emotions, right? You can also call it the sentiment, or you can also call the emotions. Okay, I just make it as a sentiment here. You can also make it as a emotions also. Now you can see I actually passing here the value from here. So see the code is nothing but like that. From flux, we input here the flux, then input the render template, because we need to also render this template index.html. We'll go further when we go to the deeper of our analyze emotion functions, then we discuss about that things. Okay, see, then we import here the pickle, then import here the regular expressions, then LLTK, the port estimator, the stopword, then numpy as np, and also importing here the download for the supports, and also creating here the stop ports in a set, and creating here the app inside my flux underscore name. Then we import, we are going to loading here all of the pickle file, that's called our logistic regression models, and also the tf idea vectorizers, and also the label encoder. So your task is to creating here the same thing, the same application using deep learning method one, because we have the model file also the bookup underscore info.pickle file, and also our lb1 pickle file. So I am going to creating here this full application using the machine learning. Your task is to creating the same application using the deep learning. Well, now you can see here you also creating here this def clean text in our file. It having the function called clean data. Okay, clean underscore data. There's the functions that's called the clean underscore data that you can see just what, yeah, clean underscore data. So in here actually make it clean underscore text. Okay, then after that we have a function that's called the predict emotions, and which one taking one input text, and you can pass it inside this clean text, and to passing these same things inside my vectorizer and transform it. And after that we can using here this predict function, and also the lb.inverse transform for getting the predicted emotions and also the labels. Simply returning this label same things. If I go inside here, you can see having the clean data method, and if I go inside the prediction one for the predicting system, you can see this predict emotion, the same thing you need to using it here. Okay, same thing you need to using it here. That's why actually using this one, this clean text, just changing this clean data to the clean text. And then we're creating here one route, the initial route, and the method is nothing but the get and the post method. See, the method is nothing but the post method. So we're taking the input from our comment, this comment. If I go inside my index.html, just from this comment, you can see name is nothing but a comment. It will take in the input from this comment, and after that it will pass this comment inside my predict emotion functions, and this one actually giving here one labels, these labels, and I'm going to pass in this label inside my sentiment. You can also make it like that, emotion. Okay, emotions. You can also do like that. Emotion and the sentiment is also same. Joy, fear, love, also sentiment. Okay. Now, if it is working, then it's simply going to render this index.html. Now let's go inside this index.html. See, inside this index.html as a render file, you're going to passing here the sentiment. We're going to passing here a sentiment. So if I go inside this index.html, if the sentiment is defined, it's called the Zinja template. The sentiment is nothing but 0. It's called the joy. Otherwise, it's called the fear. For 2, it's called the anger. For 3, it's called the love. And for 4, it's called the sadness. And otherwise, it's called a surprise. So that's the code for that how can you creating these applications using the Fox. Simple things, just simple. Now, while you're trying to creating this same thing for the deep learning, just need to using here this text cleaning method and this predict emotion method for the deep learning. That's it. And passing this sentiment inside the parameter as a render tablet, and you can get the value. Okay, now what I can do, I'm simply going to run it from here, and it will running, and it will opening this applications in our local server. So what I can do now, you can see error loading the stopword. I think my internet connection is off, that's why. Okay, let's go on here, follow link. Okay, let's go on the full screen mode, and you can see motion classifications, enter a comment. So let's say I am feeling love with you. Okay, with you, and you can see analyze. So this is nothing but called love. Yeah, I know this is called the love. Okay, let's giving here another name. So let's say she hates me. Okay, let's giving here analyze, and you can see joy. Okay, that's mean थोड़ा mistake यहाँ पर हो गया है. That's mean we need to do some changes on the code. In our index.html, this 0 means anger. Okay, 0 means anger, and this 2 means joy. Okay, 2 means joy. Okay, we can testing this out. Hope so we do some mistake on here. So now let's try to try this one again. She break up with me and analyze. Just going to click on analyze, and you can see sadness is working fine. Okay. Yep. This is how your application actually work. So if you do any mistake, just like for the sentiment, we can also checking this one, which one is for the anger and which one is for the fear and which one is for the joy. If I go inside this emotion classification using LSTM, so we can tag this one. It's called the 4. Okay, for the levels, it's nothing but called the sadness. So we need to getting all of the levels from here. So what I can do, we can getting all of the levels for that, and you can actually pass it inside my index.html and getting the value from here. This is how you actually getting this value. For 0 is called anger, for 1 is called the fear, and 4 is called the joy, and 3 is called the love, and 4 is nothing but sadness, and after that it is surprise. Okay, let's try to checking some value from our data set so that we can test it out. So just open this one. So I feel it's called Sanders. Okay, I am grabbing a minute post. I feel pretty wrong. Okay, let's test this one, and let's go on here and try to paste it here. And this one, yep, it's called anger. It's really working fine. Okay, this is also called the anger. Okay, this is really working fine now. So I am feeling romantic. Okay, romantic too. So let's go on here again, and let's click on here the analyze. And yes, this is love. It's really working fine. Now let's try to check another one. It's called I am become overwhelmed and feel defeated. अरे थोड़ा set हो गया. Yeah, sadness. This is really work that our application is really work. Just having one mistake on that for the anger and the joy. Okay, it's your work to finding this one, which one is for the 0, which one is for the 1, which one is for the 2, and which one is for 3, and which one is for the 4. Because we're using the level encoder. We're using the level encoder. So that's why this kind of mistake may be happening. Okay, in my before one, when actually creating this model using the same method, in this level encoder, I have for the 1 I have the joy. Okay, now in this model I just created newly. It's for the 0, it's nothing but called the angers. So we can also testing another one. Let's try this one. Okay, and we can paste it here, and you can see joy. Okay, you can also testing it inside your text.txt file also. Okay, and I am feeling rather rotten and ambiguous right now. Let's try to check this one. This is the testing file. We don't use it here. Okay, you can see sadness. The how really cool our emotion classification application really work. Okay, so that's it for today. Now hope you enjoy this tutorial, and make sure to subscribe to the channels, and don't forget to hit the bell icons, and I'll be back with another tutorial. Till then, take care, and also Shubha Navabarsha.